Hello and welcome. This video forms part of an instructional series covering the general use of Pion's MicroFlux, MacroFlux and BioFlux apparatus with the Rainbow R6 concentration monitor and its counterpart software, AuPRO 7.0. In this video, I will provide a walkthrough on how to prepare the Rainbow R6 and AuPRO for carrying out flux measurements with the MacroFlux and BioFlux apparatus. Please note that this video assumes user familiarity with basic R6 and AuPRO operation. In this example, we will be assaying the drug naproxen using pH 6.5 phosphate buffer as the donor medium, with acceptor sink buffer as the acceptor medium. Based on what you intend to run for your flux assay, you will need to consider how to prepare the R6 for the measurement appropriately. This means planning how the different R6 measurement channels will be used. As in this case, each of the channels will not be operating in the same medium. In the basic introductory course for R6 and AuPRO, we discuss how important it is to produce calibration curves for each R6 measurement channel in the same medium which is to be used for your assay. This is because the medium being used can in some cases influence the molar absorption of the analyte, especially so for ionizable samples in media of different pH. The sample naproxen, with a pKa value of approximately 4.2, would possess a different molar absorption profile were it assayed at pH 6.5 as opposed to pH 2.0. Other than the pH, interactions between the sample and components of the dissolution medium or the acceptor sink buffer may also affect molar absorption, so it is important to calibrate in the media you intend to use for your main assay. It therefore follows that all the channels which will be used to monitor the sample in the donor medium should be calibrated for the sample in the donor medium, and the channels which will be used to monitor the appearance of the sample in the acceptor medium should be calibrated for the acceptor medium. Further to just the potential differences arising from altering the media, other considerations should be made for the expected level of solubility and turbidity in the donor media. This will inform what path length will be used on each channel's dip probe. For samples where you expect a high solubility or high turbidity, a smaller path length may be appropriate for the donor side, either to reduce the level of detector saturation due to the quantity of sample dissolving, or alternatively, to minimize the influence of turbidity from suspended solids in the medium. We will now discuss the process of preparing the instruments for the assay which I previously described, the parameters for which are outlined in the below table. Firstly, you should determine which channels are being used for the donor and acceptor chambers. Usually, odd-numbered channels are used to monitor the donor chambers, and the even-numbered channels are used to monitor the acceptor chambers. Following this convention, the dip probes should be fitted with the appropriate path length tips. In this example, we will be using the 2mm path for the donor chamber probes. Once your instrument setup is outlined, you may proceed to collect standards. With the channels assigned and path length tips selected and fitted, you may then proceed to collect the 100% T and the standard curves by the normal process, assuming that the donor probes are used with the intended donor medium, and that acceptor probes are used with the ASB medium. When complete, you should have a data file containing an array of standard curves, with curves pertaining to the analyte in the donor medium on the odd-numbered channels being used, i.e. channels 1, 3, 5 and 7, and curves to the analyte in the ASB medium on even-numbered channels, channels 2, 4, 6 and 8. The standard collection process I will now follow is the same as the process as it is described in Part D of the R6 trading video series featuring the standardization station, though we will also briefly outline the steps involved. I will be using two separate stations, one holding together the J probes to be used in the donor medium on the left, and then a second station securing the fixed path length probes being used in the acceptor chambers on the right. The magnetic stirrers of each base are active, and the donor medium has been added to the left station and the acceptor sink buffer to the right. Remember to bring your ASB up to room temperature and invert gently to dissolve all the components before use. The probes are then lowered into position. Release the latch at the back of each assembly and lower the rack, taking care not to catch the fibre optic probes. Take care not to lower the probes too much, such that you impede free movement of the stirrers. After ensuring the probe windows are clear of bubbles, you may then proceed to collect the 100% T. Ensure there are no significant deviations in the probe's integration times, and then use the diagnostic mode to check the stability of the readings as per the process described in Part D of the R6 training series. Once you are certain the probe performance is stable, you can begin collecting the standard spectra. By the process described in the series of basic training videos for the R6, prior to using a data file containing standards to measure concentrations in an assay, you would perform the sample blank procedure to renormalize the instrument in the assay medium. However, in this video I will describe an alternative and more practical approach to handling standards for FLUX, and indeed for other assays as well. This is known as the blue standards procedure, and it involves exporting the standard spectra obtained in an AuPRO data file into a format which may be re-imported to any other existing file. This process serves as an alternative to performing a sample blank. The process of converting standards into blue standards saves the concentration information of each standard spectrum, in addition to the absorbance versus wavelength spectra themselves. This intrinsically makes the standards independent of the 100% T in the data file which was used to produce them, which means they may be imported to any other AuPRO data file and reused as many times as required. Like normal standards, remember that blue standards must still only be used under the same conditions as which they were measured, the same pH, and the same media composition. Using blue standards with a different probe and path length tip combination can also introduce errors due to path length variance, so this should be avoided. Lastly, avoid using blue standards on instrument channels other than the ones they were initially collected on. As an example, here we have our completed set of standards for naproxen, collected in pH 6.5 phosphate buffer on channels 1 and 3, and in accept sync buffer on channels 2 and 4. Rather than use the sample blank, we will instead export these as blue standards. To do so, right-click on any one of the instrument channel graphs and select Export All Standards. Then, select a location to save the exported standards to. It is advised to create a new folder to contain each new set of blue standards. This will make exporting them to new data files easier going forwards, as each export produces a large number of files, one for each standard collected on every instrument channel in the source data file. With the standards saved, they are ready for export into any new AuPRO data file. This concludes our video on how to prepare the Rainbow and AuPRO for flux measurements. The next video in this series will address carrying out the flux assay itself, and how to refine datasets to obtain flux values.